Hi folks, this video has been developed exclusively for beginners who want to understand artificial intelligence. Artificial intelligence is to make machines learn to do things which at present human beings do better. Machine learning is basically a subset of AI. Machines should be able to perceive knowledge and take decisions based on it. Artificial intelligence can be made without machine learning also, but requires thousands and thousands of lines of coding or programs. Deep learning is a subset of machine learning. It uses artificial neural networks. Some of the applications of AI are gesture recognition, speech or voice recognition, facial recognition, robot navigation, etc. Intelligence requires knowledge. The knowledge properties are hard to characterize accurately. It's voluminous in nature and it's constantly changing. AI techniques exploit this knowledge that should be represented in such a way that it captures generalization. It means properties are grouped together and can be well understood by the people who provides it. Error modification is made possible. It can be used in many situations. It also reduces the bulkiness and narrows down the range of possibilities. Therefore, we can say that knowledge is needed to build intelligence. Now, let us see the task domains of AI. This can be categorized basically into three. They are mundane tasks, formal tasks, and expert tasks. Mundane tasks means everyday activities such as perception of vision, speech, generation, control and translation of natural language understanding and common sense reasoning. Formal tasks includes games such as chess, checker and mathematical computations like algebra, geometry, integral calculus and so on. Expert tasks includes engineering, medical, scientific, financial, etc., which needs skills and expertise. This task requires symbolic reasoning, which is represented symbolically, depth, which indicates complex rules to handle difficult problems, and self-knowledge, which means self-evaluation, examination, reasoning, and then do the operation. In order to build a system to solve a problem, we need to define precisely certain things. The initial state, the final state, and the specifications of the problem need to be stated correctly. To find the suitable technique needed to solve the problem, first isolate and narrow down the knowledge according to the problem and finally choose the best solving technique. To characterize the AI technique, we will discuss the 8 queens problem. The queen in the chessboard can move horizontally, vertically and diagonally anywhere in the chessboard as shown. How to place the 8 queens in the chessboard so that none of them attack each other. Basically, there are 64 squares in the chessboard. 8 queens are to be placed, remaining 56 blank squares. Hence, 4,426,165,368 ways of placing it. Here we are not solving the 8 queens problem but trying to understand the complexity involved in writing the programs to make the machines understand. Let us define three basic criteria. No two queens should be placed adjacent to each other. No two queens should be placed in the same column. No two queens should be placed in the same row. A procedure to find all possible attempts to place a queen in a given square and then place another and so on till it satisfies all the criteria. There are 12 fundamental different solutions. This includes rotating the board and deflecting the board. 11 of them has 8 deflections and rotations and one of them has 4 deflections and rotation. If we take all possible combination, there are 92 distinct solutions made possible. In the figure, one of the solutions of 8 queens problem is shown. Here the first queen is placed in the third column of the first row, second queen in the sixth column, and third queen in the second column, and so on, so that none of the queens can attack each other. A second solution in another order is also given. Like this, 12 distinct solutions can be made possible. But there are several other issues that crop up while solving these problems. The other issues are initial calls to place the queen, how to represent the chessboard, how to check whether the placing is correct, whether the placing puts the queen in immediate danger, etc. This issue shows the complexity, generalization, clarity of the knowledge required in solving artificial intelligence problem. In order to conclude, we can say that AI techniques illustrate search, use of knowledge, and abstraction. Abstraction helps in separating the important from the unimportant, whereas search solves a problem without direct approach but with framework into which direct techniques can be embedded. It uses the knowledge that provides a way of solving complex problems by exploiting the structure of the objects that are involved. This brings to the end of the session. Thank you.